All right, so now we need to take a look at how we're actually going to deal with significant digits when it comes to doing mathematical operations. And it matters because we don't want to be more precise than we actually are. Just like the zeros that we had, were they significant or not? We can recognize if a digit is significant, but we have to be sure that we do not over-report our precision when we add things together. Okay, so here's an example. If we take 2,000 meters and we add 1 meter to it, in significant digits, we still have 2,000 meters. Why is that?
Okay, that seems very confusing, Mr. Howard, because 2,000 plus 1 is definitely 2,001.
How many significant digits do you have here?
Well, that would be 1, because we say that the last zeros aren't significant. They're just placeholders. They're showing that the number's big.
Right. So could this have been 1,999 meters?
Probably, yeah.
Could it have been 1,700 meters?
Yeah, sure, if they rounded up to the next one.
Sure. So what's our range on this actually? Well, okay, since it's only precise over here to the thousands place, we know it's somewhere between 1,500 and 2,499.
Oh, wow, that is a big range.
So if we add 1 meter to it, nobody cares because we don't have precision within 1 meter. We could add 100 meters to it and we wouldn't really care.
Okay, so what you're saying is that 2,000 wasn't measured with a very good tool. It was a very big guess when we came up with that 2,000 measurement.
It'd be like if you were walking across a football field and you want to know how long it was and you were measuring your steps instead of measuring, you know, with a stick. You know how many steps it was, but you don't know how many inches it was.
Right. So it's a big estimate.
It's a big estimate. Okay, so we don't want to say 2001 because that's saying, oh, we know exactly 2001. We don't. We know it's 2,000 plus or minus 500 meters.
Now, what if we had a good tool and we actually did hit 2,000 meters?
Okay, so if we had recorded that number, remember, we'd have needed to record it at like 2,000 decimal point.
Okay, or in scientific notation.
Or in scientific notation. And then if we added 1 to it,
then we could say 2001.
Then we could say 2001.
Okay,
meters.
that makes sense. So I don't want to be, or don't want to imply I'm more precise than I really am.
Exactly. Okay, so let's take a look at just addition and subtraction. Now there's 2 different operations, right? There's addition and subtraction, and there's multiplication and division. And the rules are a little bit different for both of them. Addition and subtraction is pretty easy. It says our final answer should have the same level of precision as the least precise measure. Now remember, precision is how many decimal points did you go to?
Okay, so in the first one, if I were just to do that in my head or in my calculator, well, hopefully I don't need my calculator for this, I should get 37.45 meters.
So 37.45
But
meters.
I'm going to have to do some rounding. It looks like I'm to the ones place on my precision, on my least precise measurement.
Right. How did you recognize that that was the least precise?
Because it's a 2 and it's to the ones place, whereas the previous number is to the, that'd be tenths, hundredths place.
Okay. So this one has no decimal points at all, and this one has 2. So this is our least precise measure. So this could be 2.1, 2.22, 2.4, 1.6. We don't know exactly what it is. We know it's around 2. So we take 35.45 plus around 2 meters, and we get 37.45. But since our 2 wasn't this precise, we can't be this precise anymore.
So I want to report 37 meters for my final answer.
Is going to say 37 meters. It's precise to
the ones
place, just like this one. So since we had no decimals here, we can have no decimals here.
Okay, so on the next one, if we were to just plug that into our calculators, 93.8 minus, that's a minus this time.
Plus a negative, 3.15.
3.15 kilograms.
Okay.
So that'll get us, let's see,
90.65 kilograms.
Okay, so my least precise measurement this time looks like my first one.
Okay, because that one's precise to the
ones, or the tenths place.
And this is precise to hundredths, but we're not here.
Okay, so I want to round my answer to the tenths place, so that last digit's a 5, which makes me go up to a 7.
90.7 kilograms. All right.
Ooh, this one looks tricky.
Okay, now let's do a quick review. How many significant digits are here?
That one's just 1, because all those zeros at the end are placeholders.
Right. Okay, so we can do the math. We can take 3,000 minus 10.
Okay, that would be 2990.
Okay,
right? But that's kind of like our first example we had.
We're only precise to this place, so we're going to round to the closest this place.
So 3,000.
So 3,000 seconds. Okay, so we're back to where we were. Since this wasn't as precise enough to know,
taking away 10 seconds doesn't really matter. Okay.
Oh, well, now this one, pay attention.
Okay, I've got centimeters plus meters. On that one, I don't want to add centimeters to meters because remember in addition subtraction, our units must match.
Have to match.
Okay, so we got a hint down there. Rewrite with the same units. 0.45 plus 1.2 meters.
Okay, so we converted these centimeters into meters, and so that's going to get me
so 1.65
meters.
And then rounding to my least precise,
right
there would make my answer 1.7 meters.
1.7 meters. Now, you could have put it in centimeters just as well, and this would have been 0.45 centimeters plus 100...
Oh, you mean 45 centimeters.
Or, sorry, 45 centimeters plus 120.
Yep.
And then this 0 is not significant, so we still only have these two. So we'd have had 165 centimeters, but we'd have needed to round that
to 170
centimeters. Okay, so we have the same equivalent answer either way. All right, so now let's take a look at multiplication and division. I think this is a little bit easier because before we had to recognize how precise a measure was. Now we just have to say, well, how many significant digits does it have? And that's what we're going to go with.
Okay, so that's why we already learned how to count the number of significant digits.
Right. So this
we didn't really have to do that in the last one.
This one has 3.
3.
This one has 2.
So my final answer looks like needs to have 2.
2 significant digits.
So I got my calculator because that's hard for me to do in my head.
So 3.45 times 1.2.
My calculator tells me it's 4.14.
4.14.
And I better use correct units.
Square meters.
Meters squared, right?
Because meters times meters equals meters squared. And so this, I need two
significant figures, so 4.1.
4.1 square meters. Okay, and that would be the final answer I report. Now, if you have multiple steps in your calculation, you can carry through these extra decimals until the end and just round at the end.
Okay, the next one, 30 times 5.5.
Is this 0 significant?
No.
Okay,
it's a tricky one.
Right, that's at the end. It's holding a place. It's telling me this isn't 3, it's 30. So 3 times 5.5.
That gets me 165. You already did it in your head.
165 square meters.
But I only want one significant figure, so...
Okay, so 165. This is going to round up, so I'm going to go 200 square meters. Okay, that's a big difference, but it is as precise as we can be.
Right.
Okay.
Okay, 425 divided by 15. So I've got my my calculator tells me it's 28.33 repeating.
333 forever.
Okay.
Meters per second.
Now the first number has 3 sig figs, second one 2 sig figs. So I only want my answer to have 2, so get rid of that.
I don't have to deal with that fraction.
Meters per second.
Cool. All right, and then here's another one. Now, in addition, subtraction, multiplication, and division, okay, addition, subtraction units have to match. Multiplication and division, they don't, but if we're measuring the same dimension, okay, they should. Okay, so this one measures length, this one measures length. Together they're measuring area because we're multiplying them. We want those units to match.
Right, it wouldn't make sense to have something meter centimeters.
Meter centimeters. Okay. So
it would make sense maybe to have meter seconds or...
Meters per second or meter seconds or something
that might
like
make sense, but not meter centimeters.
Not meter centimeters. So we went ahead and converted these into meters, 7.5 meters and 2.5 meters.
Okay, I got 18.75 in my calculator.
18.75 square meters. Now, significant digits, 2
here. 2 sig figs, so let's round that to 19.
So 19 square meters. Okay.
Great.
It's as easy as that. Multiplication, division, like I said, I think that one's easier because we just figure out the least number of significant digits, and that's how many we get.
Looks like the biggest thing we need to pay attention to is knowing which rules to apply to which situations.
Right. Is this significant? No, it is not. We don't get to count it. So that's why we didn't write 2.50 meters. We wrote 2.5.